Hello friends, this is Dr. Sudhanshu Sharma from School of Computers and Information Sciences, and this is second session for advanced option in spreadsheets. And the objectives of today's sessions are that you will be able to analyze the data using descriptive statistics, and you will be able to understand correlation and regression for decision making over the given data set. Now, firstly, to use the descriptive statistics option, you need to understand that there is a facility called data analysis tool pack, which is not available by default onto the Excel sheet. You need to explicitly install it. This is a hidden facility. And to install that data analysis tool pack, some of the steps have to be followed. That means firstly you are supposed to go to the office button and then go select the Excel options. After selecting the Excel options, you are supposed to click the add-ins. The moment you click add-ins, a window appears where you are supposed to go to the manage section option, where you are supposed to select the analysis toolpack option. The moment you click the analysis toolpack option and press OK, it will be installed. The moment it is installed, you will find that within the data tab, the option of data analysis appears. Now it is your system, your Excel sheet is ready to use the descriptive statistics option. This mechanism actually, the data analysis tool pack helps you to perform hypothesis testing and correlation, regression study, and descriptive statistics, and various options are available. You can go for Z test, F test, T test, chi test, and many options are available in this, and it is quite useful mechanism to you should understand very clearly that how to apply the data analysis tool pack. Now, why descriptive statistics is taken at first? Because there are two types of statistics. First is descriptive and second is inferential statistics. The descriptive statistics actually describes about the data. The features which actually describes about the data are in fact your mean, mode, median, skewness, kurtosis, standard deviation, and range. These are some of the parameters which explicitly describe that what your data is all about. So you need to understand the statistics to understand the results which are being reflected after the analysis of any spreadsheet. Now, secondly, the help of descriptive statistics is that you need not to explicitly write formula for each. Likewise, to calculate mean, you need not to explicitly write the formula average and select the range and so on and so forth. You need not to devise your formula for calculating the other options. Likewise, you can go for the you can get the correlation parameters without using the correl function and so on and so forth. So it is a quite useful function. So let's understand that how to use the descriptive statistics option. The moment say you click the data analysis tool pack tab, the data analysis tab under the data option, the moment you click it, the descriptive statistics part will be reflected in a window where the data analysis is written at the top. So the moment you select the descriptive statistics and press OK, again a window appears where different options are available. So first option is that you need to incorporate the input range. That means where your data lies. Secondly, you are supposed to specify that your data is grouped in a column manner or a row manner. Likewise, say the columnar collection of the data is there or row wise data collection is there, and accordingly you're supposed to find that the result should be given onto the same sheet. If you choose the position that on the same sheet you want the results of the descriptive statistics, then you select the cell position and accordingly the results will be reflected. So let's understand the application of descriptive statistics by applying it on the case. Say we are having a player whose statistics is available that within say 15 matches the person has scored different runs, and we want that what is the average score. We want to have the statistics of that particular player. then how to use Excel to have the statistic, that what is the mean, mode, median, standard deviation, variance, skewness, kurtosis, and different parameters. So you need not to worry about it. You just click on the data tab, select the data analysis option. The moment you click data analysis option, the window appears, and within that window you select the descriptive statistics option, click OK again, and one more window will appear, and in that window you pass on the input range. The input range, you want to have the statistics analysis for the score, so you collect the entire column score, and because the score, the data is recorded in the columnar manner, so you select the option that in the column wise the data is recorded, and with the things that there is label in the first row, this will be checked, and then you select the position by selecting, say I want the result on the same sheet, so I select the cell position where I want the descriptive statistics result, and after that I select the descriptive statistics option, and at a 95% confidence level or whatever your requirement is, then press OK. The moment you press OK, the position which is being selected where you want your data, your descriptive statistics should be there, will be reflecting the statistics of that particular player. So it will be carrying the information, likewise your mean, mode, median, standard error, standard deviation, skewness, kurtosis, range, minimum and maximum, sum and count, and all the parameters are reflected, and you will be thrilled by looking at the data, and you can use the data into your research. So within one go you can have a number of parameters. Now the second important feature which is available in this data analysis tool pack is to work with correlation and regression. Correlation and regression are very important parameters, be it the line of, say, dimensional reductionality. Many a times you are having multiple columns into the data set, but few of the columns are relevant. So how you will find that how many columns are relevant? Then in order to perform the relevant analysis of the data, you are supposed to go for the correlation study. We are not going to discuss the actual mathematical component of correlation analysis over here, but the base points are to be discussed, that correlation identifies that whether the two variables are correlated or not. Now to understand the level of correlation, you are supposed to evaluate the correlation coefficient. If the correlation coefficient values are lying between -1 and +1, if they are close to 1, that means they are strongly correlated. Now if the value is close to negative of 1, say 0.9 or 0.95 or 0.89 or so and so forth, that means value is close to 1, then you can say that the data are negatively correlated. That means one is increasing, the other is decreasing. And if you go for the positive correlation, that means both are directly correlated. So there are different coefficients. Carl-Pearson coefficient of correlation is there, and different formulas are there. So you can devise your own formula by actually writing the formulas and functions, which were the concepts were already taught to you in the past sessions. When we discussed about the formulas and functions, you can devise your own formula, or you can use the default function, which is a Correl function, CORREL, and you will pass on the values among which you want to establish the correlation, you want to study the correlation. And lastly, you can use the data analysis tool pack. Within this tool pack also the correlation option is available. So the standard formula for coefficient of correlation is simple mathematics is there. Say there is a scenario that you want to study the relation that you are having a computer, and you want to study the performance of the computer. What is the variation in the performance of the computer when you change the size of the RAM. So you conducted an experiment that you changed the RAM size, and you evaluated the performance of the computer and recorded the performance parameters, and you develop your Excel sheet. Now you want to study that is there any relation in between the RAM size increasing the RAM size and the performance of the computer. So one of the mechanism is that is there any correlation in between the two parameters. So you recorded the data, say there is a change in performance, you record it under the head X, and you want to record the say you want to know, so you recorded the data of change in RAM size, you are taking it as an independent variable X, and because the you want to study the effect of change in RAM size over the performance of the system. So the performance of the system is actually dependent on size of RAM. So the performance variable will be the dependent variable, that is Y. So as per the formula, you are supposed to calculate the square of each and every value of X, square of each and every value of Y, and product of each value of X with each value of Y. Then you devise the formula accordingly. Likewise, as it is discussed, summation of xi yi minus n into x bar y bar divided by square root of summation of xi square minus n x bar square multiplied by square root of summation of yi square minus n y bar square. Now y bar and x bar are also to be calculated, that is average of x values and average of y values, and you devise the formula and you will find that the correlation value turns out to be 0.96. That means there is a strong correlation in between the performance of the system and the change in the RAM size. Now let's apply this study by using the Corel function. We can use the formula equal to Corel and select the entire X range, that is from A2 to A13, and the entire Y range, that is from B2 to B13, and just press enter, and we will find that the return value is same again, 0.9615, which is same as we calculated it through our formula. Now we can use the descriptive statistics option also. You can directly go to the data tab, select the data analysis option. The moment you click data analysis option, the data analysis window will appear, and from that data analysis window you can select the correlation option and pass on the parameters, that is x and y parameters, and you will find that again the reflected result is 0.9615. So you will find that there is a strong correlation, because and that correlation is also positive. That means with the increase in RAM size, the performance of the system is also improving in a positive manner. So this is the usage of the correlation function. And now we are supposed to discuss something about the regression. Now regression is actually a mechanism to predict. That means if you know some data, on the basis of the data you want to predict that what will happen, what is the trend of the data. On the basis of data or trend you can predict that this may happen. So regression shows the influence of some values which are independent or substantive ones on the dependent variables. And it is not like that the regression will be only linear. It may be parabolic, exponential, power, hyperbolic or logarithmic, but generally to begin with, let's discuss the linear regression. And the linear regression follows the equation of y is equal to a plus bx. Whereas we all know that the quadratic equations are parabolic in nature, so the regression equation for parabolic part will be equal to y is equal to a plus bx plus cx square, which is a quadratic equation. So by looking at the right hand side, we can identify that this type of trend will be a parabolic trend and the regression will be parabolic regression. Similarly, the exponential regression, the mathematical formula will be equal to a into e to the power bx. Now exponential trends are there, so this will be taken care by the exponential regression. We are also having the power regression, where which is catered by the formula y is equal to a into b to the power x to the power b. And so on and so forth. We are having hyperbolic and logarithmic regression. But to begin with, let's start with the linear regression. You will be able to understand it well. And this concept actually helps you to construct the regression model in Excel, and by using the data analysis tool pack, you will be having the values like R and R square values, and we will be discussing how to interpret the results which are being returned by the data analysis tool pack. To deal with, let's take a task that say company is there, the statistics of a company is to be analyzed, where we are having the average monthly salary of the number of employees who retired. So friends, we learned how to apply the formula for correlation, and we also devised our own function, and we also evaluated the value of correlation by using the data analysis tool pack, and we find that there is a strong correlation in between the size of RAM and the performance of the system. That means there is a positive correlation because the value is very close to 1.96 is quite close to 1. There is a positive correlation, that means as the size of RAM increases, the performance of the computer system is also improving. So this helps us to understand that there is a impact of the size of RAM over the performance of the system. So we studied this. Now the next important concept is the concept of regression. Actually, the concept of regression is used to predict, and we are supposed to study the trend of the data. On the basis of the trend of the data, we can predict that what will happen, what could be the future value of for a particular dependent variable. So regression actually shows the influence of some values, and that is the independent or substantive one on the dependent variables. So regression is not restricted only to be a linear type. It could be parabolic, exponential, it could be power, hyperbolic or logarithmic type. The linear regression follows the equation of line, which is standard, that is y is equal to a plus bx. And we all know that the quadratic equations are parabolic in nature, so the regression equation for the parabolic regression will be quadratic in nature, and that's why it is equal to y is equal to a plus bx plus cx square. Now so far as the exponential regression is concerned, we are supposed to understand the mathematical equation, that is y is equal to a into exponential to the power bx. Now exponential function is used over here, as a result of which the trend will be exponential. Similarly, we are having the power regression, where the trend is taken care by the mathematical equation y is equal to a into b to x to the power b, and we are having hyperbolic and logarithmic regressions also. Now linear regression is quite simple, and we start with the linear regression. And so to understand the linear regression concept, let us take a task, and we solve this task by using Excel. Say a company wants to study that whether there is a dependence of number of employees who retired from the company and their average salary. So in order to study this, say there are companies, a group of 6 companies is there, and where different employees are there, and they are having different salary packages. So they are retired. At the time of their retirement, their salary packages are recorded, and we are having the data, that is the number of employees who retired and their salary packages. Now we want to incorporate the linear regression model, and the linear regression model is, as already said, is of the type y is equal to a plus bx. Now we can have different independent variables, so the linear regression equation may expand to a naught plus a1 x1 plus a2 x2 up to a n xn, where a are the regression coefficients, x is the influencing variable, and k is the number of factors. Now in our example, y serves as the indicator of employees who retired, because we want to study the employees, and the influence factor is in fact the wage, that is x. Now we can simply use the data analysis tool pack. Just go to the data tab, click the data analysis option, the window will pop up, and from that window you select the regression option and click OK. Then you pass on the x and y fields. That means you select the employees table and your wages part, that is the salary part. The wages are in fact independent, so they are taken care under the head X, and the employees are dependent, so they are taken under the head Y. Now the moment you press OK, the R square statistics, different statistics are visible. Now you should not worry about that what are these numbers all about, because you are supposed to learn the statistics. The Excel will only, the softwares only return the values. Now it is your skill to analyze these values. Now firstly focus on the R square value. The R square value is actually the coefficient of determination, and in our case the value returned for R square is 0.7547, or you can roughly say that 75.5%. This means that the model parameter estimates at 75.5%, and 75% of the data explains the addition relation in between the parameters which are studied. The higher the coefficient of determination, the better is the model. So this model is quite good, and regression equation is quite satisfying the data which is available. So R square identifies that if the values are quite close to 1, say near about 0.8, it's considered as good, and if it is less than 0.5, the model is considered bad. Since the value is close to 0.8, so the model is quite good, and the linear model actually explains the data. Now a second important factor is in fact your you need to understand the coefficient which is given as the intercept part. In the very last row you will find that X variable 1, that value is minus 0.16285 ratio. Now the minus 0.16285, you should interpret that negative sign indicates the effect that higher the salary, the less are dismissed, and you will find that this is quite true from the data, that those persons who are having the higher salary are quite less in number in comparison to those who are having lesser salary. So the dismissal rate for the person having higher salary is quite less. You can verify the result of minus 0.16285 by studying the same data by using correlation factor. The moment you study the correlation parameter by using the formula equal to correl, and you select the data range from B2 to B7 and C2 to C7, which relates to the employees who retire or employees who are dismissed, and C2 to C7 which relates to the salary at the time of their retirement, you will find that the correlation parameter is 0.8687, or roughly it is 0.87. So it is quite close to 1, so there is a positive correlation, and the result returns are minus of 0.867. So that means this is negative correlation. That means this establishes that the persons with the higher salary are less dismissed. This negative correlation verifies the result returned by the intercept section of the data returned by your data analysis toolpack. Now after going through these concepts, I hope you are in the position to interpret the results returned by the data analysis toolpack, and you are in position to understand the regression part, that how to analyze the R square statistics, how to analyze the intercept part, how to verify the intercept part using the correlation parameter, and you learned about the concept of the correlation and the verification of the correlation parameters by writing your own formula, by using the well-defined formula correl, and by using the data analysis toolpack functions. Now after that you also learned about the relevance of descriptive statistics, and I hope after going through all the concepts which are being delivered in this session, you are in position to apply and understand the statistics part in a better manner. Please exercise the concepts which are taught. The more you exercise, the better it will be. Thank you very much.